Hi, everyone, and welcome to Cloud Native Live for today, Wednesday, July 10th, 2024. I'm Taylor Thomas, and I'm your host today. And here in Cloud Native Live, we have the opportunity to meet the different people behind the people and technologies that are behind Cloud Native and how they work. We kind of look at and see how everything gets to work under the hood. And so, as a CNCF event, this is governed by the CNCF Code of Conduct, which basically boils down to please be respectful and nice to each other. So in the comments and questions you ask, please be respectful to one another, and we'll have a great live stream today. We're excited to have today with us Paul from Isovalent, who's going to go ahead and give us some more information on Tetragon. So Paul, do you want to go ahead and introduce yourself?
Hi, good afternoon, good evening. My name is Paul. I work at Isovalent at Cisco. I'm a community builder focused on security, and we have a couple of security focused projects. And today I will be talking to you about Tetragon specifically, and I'll be talking about Tetragon's Kubernetes filtering capabilities. And yeah, I look forward to doing this with you. All right, so to start off, I will start off with talking about what Tetragon is in the first place. So if this is the first time you heard about Tetragon, this is going to give you an overview of what Tetragon is, right? So Tetragon is an eBPF based security observability and runtime enforcement tool. So to start off, to break this down a bit more. So eBPF, if this is the first time of you here, eBPF has been popular lately in the infrastructure world, but if this is the first time of you hearing about it, so I'm going to give you a bit of some background to this, right? So eBPF is basically a technology that allows being able to dynamically program the kernel. So if you think of the Linux kernel, right? So so many companies, so many people depend on the Linux kernel, right? And you can just wake up one day. You can't just wake up one day and say and ship a change to the Linux kernel because stability is is valued very much in the Linux community, right? You have a lot of very important infrastructures running on the kernel, and you wouldn't want to make changes to that, right? But so one of the major problems that eBPF solves is allowing us to modify the kernel for our own specific use cases, right? So for example, you can have a change you want to make to the kernel, right? And instead of you waiting for a patch to go through, and by the time it comes down to your maybe say your end user distribution, say Ubuntu, for example, you can actually modify your own version of the kernel you're using and ship these changes. So eBPF also, one of the major advantages eBPF comes with, it comes with some major performance increase, right? And we've seen eBPF being applied in different parts, right? You've seen eBPF been applied to networking, been applied to observability, been applied to security. And this is where Tetragon comes in, right? Tetragon actually leverages eBPF to do security observability, right? So security observability is an evolving field that's relatively new compared to what we would see traditional security as, right? So security observability is more about so if you think about observability the way you say from an SRE perspective, right? You're collecting lots of data, right? And then you're using this data to inform you about the state of say for example, you're collecting metrics about how your application is performing, and then you're using this to inform you about the state of your application, right? The same thing applies if you think of it from a security perspective, right? So you're collecting security relevant data, and you're using this to make a decision about from a security perspective, the state of your system. So runtime enforcement is basically, for example, in the process of you collecting that data, you notice an abnormally something that's out of the way, something that's malicious, for example, right? You want to be able to stop that in the tracks, while immediately you notice it while it's happening, right? So that's where Tetragon comes in. Tetragon is eBPF based, and because this relies on eBPF, all of this happens in the kernel. So you've got the kernel, right? You've got the kernel on the other side, the kernel space, where all the the bridge between the operating system, right? And then you've got the user space in where typically application developers will do this, do their everyday use, right? So Basically, what Tetragon does differently, relying on eBPF, is like much of this collecting of the data, the security observability, and this runtime enforcement all happens like in the kernels, right? So the advantage this comes with is this comes with very huge performance increase, because then you don't have to like ship all those events to the user space and process them, right? Everything happens in kernel. All right, so if you want to know more about Tetragon, you can just go to the Tetragon website and the documentation. It has everything all detailed. So today I'm going to be talking specifically about like how Tetragon like sort of works in the Kubernetes environment, right? So one of the biggest thing about it, one of the biggest reasons why you should use Tetragon, obviously, is that because Tetragon is like cloud native aware, it's Kubernetes aware. So you can actually take, when Tetragon collects like the security observability data, it collects them with context, with awareness about Kubernetes context. So you can have like, say, for example, you want to know which say process executed a binary, but then Tetragon is able to tell you, marry that with Kubernetes context data. So for example, you can know which specific pod executed that binary, in what specific namespace was that execution done, and all of that's cloud native contextual data, right? So let's dig in. Let's dig in. Right. To get started with Tetragon in Kubernetes, right? We've got you've got the major way to the easiest way to get started with Tetragon in your Kubernetes cluster is basically by just installing using like the Helm chart. So we have like a publicly available Helm chart you can use, and simply just install Tetragon and get going with it. You can find them. You can find them here in the documentation. You can also, I think there's a reference to it on the live stream. You can also see it there. All right. So in our case, so let's come up. We still need a bit of more background before we can dig in and get started. So there's certain constructs sort of like that Tetragon has. So we'll start with something called a tracing policy, right? So a tracing policy is basically the primary way is the way you tell Tetragon you tell Tetragon basically what to do, right? And what to do, and if basically you tell Tetragon what sort of like things you want Tetragon to track to observe, right? And what to do in case like you observe, let's say, an abnormally. So for example, say you're watching for like a specific file path, and you, for example, like the /etc directory, right? And you know, like no one is supposed to be writing to that directory, for example, right? So you can tell Tetragon, hey, look at the specific directory, and if someone is writing to this directory, the process is trying to write to this directory, kill this process, right? So that's sort of like what a tracing policy is. So a tracing policy comes as a Kubernetes custom resource. Though it's a Kubernetes custom resource, if you're using Tetragon both in like a Linux environment or in a container, it still applies like the same way. All right, so let's just see what a basic tracing policy looks like. So a basic tracing policy basically looks like this, right? So if you look at the tracing policy, we basically have different parts of it, right? So we have like, these are like the required fields, right? You have a hook point, and I'll get to these in a bit. So basically, the hook points are sort of like, so this is sort of like the different parts in the kernel where you can hook into. So we've got like care probes and trace points, and then we have our selectors. Basically, think of this as like the name implies, right? Sort of like what you're matching on, right? And then you have like the actions, right? So for example, if you match on a specific condition, what do you want to happen? So this is where like the enforcement action comes in, right? So you have the option of, for example, sending like a signal to kill the process, or for example, like overriding like the return value from like a function. All right, so that's sort of like the brief overview of what like a tracing policy looks like. So now in the context of Kubernetes, and this is sort of like the main deal for the day. This is what we will be focused on, right? So Tetragon's in kernel like filtering mechanism like offers if you're working with if you have Tetragon installed in your Kubernetes clusters, right? Your Kubernetes cluster, Tetragon in kernel filtering mechanism offers you like different filtering options where you can actually filter. You can filter how you want like a policy, where exactly you want like a policy to be applied to. For example, you can filter, you can say, hey, I want this policy to be applied to a specific namespace. I want this policy to be applied to only pod with the specific labels. I want this policy to apply to this specific container with this specific container name, right? So that's sort of like where this comes in. So this is basically like the tracing policy define what Tetragon should react to and how. So for example, um, you might want to react to someone making like an external when you notice someone is opening like a TCP connection or trying to make an external connection and you know like your application isn't supposed to be trying to like reach like the outside world, right? The application is not supposed to be opening a TCP request to like a external service or something. So obviously that's something that's suspicious, right? So with the tracing policies, you can configure like, hey, I want Tetragon to look out for this certain thing. And if it matches the specific condition, this is how I want Tetragon to react to it. I want, for example, like I want Tetragon to override like the return value or send like a signal. All right. So uh, applying like this tracing policies to a subset of like pods running in your cluster. So to get started, I prepared a very simple demo environment. I will be using Minikube. I will be using Minikube in my case. Right. So if you want to follow along, you can clone like the Tetragon project on GitHub and just come to the parts of the docs that says Kubernetes identity aware policies, and you can just follow along. All right. All right, so we've got a couple of options. We've got filtering by namespaces. We've got filtering by pod label filters. We've got filtering by container filters. To start up, so just another thing I want to also touch on is that basically, if we want when we want to ensure like a tracing policy is like correctly applied, right? Tetragon needs to perform like some of these actions before like the containers actually start executing. So this is done using like OCI runtime. Um, this is done using like OCI runtime hooks, right? So if you clone like the Tetragon projects, if you clone like the Tetragon projects, if you look in this directory contrib RT hooks minikube container, you actually see like you could actually just do this. You'd actually see like the scripts that sort of like sets this up. All right, so to get started, I'm just gonna take this and I'm gonna start up a very simple minikube cluster. So I sort of like had all the images pre-downloaded before this, so
It's still brave, though. This is how you all know this is a live demo because someone's setting up a Minikube cluster just like on the fly here.
yeah, I sort of like pre-had like the images downloaded, so it should be pretty much straightforward. All right, and we should be good. Let's just check just to see. All right, so I just want to confirm that the Tetragon pod and the Tetragon operator are both running. Yeah, okay, right. We have the both of them running. So let's just get the name of the Tetragon pod and just keep this in a variable. it will just make our lives easier as we go on. All right, so we'll get this. System logs. See. All right, so we actually want this is supposed to be for the Tetragon operator. All right, so
Oh, looks like we might have had a internet hiccup, so give us all just a second. Yep, sorry all. Looks like we're having some brief technical difficulties. We'll be right back. Of course, it was right in the middle of the demo too, but we should be able to pick up just fine. While we're waiting, in case those missed, I'll show the links once again for those who might be following along. This is the link to the filtering docs that are inside of Tetragon. So if you were following along, that's the way to do that. And then we've got Paul back. Great. Perfect. Back, Paul.
Are you having so your GPs are running the
You can see it, Paul, but we can't hear you right now.
Okay, so they're running the top person. So in that case, they might still require you.
Yes, can you hear me now?
Yes, we're back. Okay. Thanks for
sorry
sticking
about
with us. No, it's fine. Thanks for sticking with us, everyone, as we have those technical difficulties, and we'll get you back to your demo. Paul, go ahead.
Yeah. Where did you lose me?
You were in the
Just
middle of
get
the terminal starting to show off some of the stuff, and then we lost you. We lost your audio again, Paul.
Okay.
Yep, we're good now.
Anything else
All
on
right.
that topic? Would you like
Yeah.
to
Sure. Today's being a funny day.
Okay.
Okay. So all right. So we basically want to confirm. We want to confirm that policy filtering has been enabled. So we just look through like the logs. We look through like the logs just to see that policy filtering has been enabled. But you can see like the highlighted one here is basically like it's basically the highlighted one is here basically policy filtering has been enabled. All right, so the next thing in the we're just gonna run like a very simple. We're gonna run a simple.
Paul, we lost your audio again.
And this can be saved in the project template. So that kind of created as far as the category, the stuff and deal, and then you can kind of import that. I guess
Still no audio, Paul. Sorry.
Are you following with me?
Oh, here we go. Now we're back. You're good now.
All right. Yeah, my ISP's been stay. All right, so yeah. So the way this is gonna go, basically, like the end goal of this is we basically have the system call, right? So we have the system call called LSIC, right? So basically, what system calls are think of when you have like system calls. I think of them sort of like as the bridge in between like the in between like the user space and the kernel space. So for example, when you want to like an operating system function, like you want to like read from a disk, right? You have like a specific system call that does that. So your application, typically your application will reach out to the system call, and the system call will then go to the kernel and perform like will reach out to the kernel and perform this action. So sort of think of a system call as sort of like the bridge, in between like the kernel and the user space. So your application won't directly like just read from disk, right? Will have to like go through like a system call would have to go through like a system call that does this. And in this particular case, like the goal, what we're trying to demonstrate here is that we have this L6 system call, and basically,
Paul, do you want to share your screen again? Wanted to make sure people saw it. So
right.
you're good.
All right. So now, okay. All right. So No, this system call. We are not going to try. We are now going to basically start up a very simple Python. Okay, I think I already have a pod like that.
And then I could draw square.
Paul, we lost your audio again.
Okay. What that does is that creates an instant.
Okay, I'm not really sure what's.
Oh, now you're back. Now you're back.
Okay, all right, so what we're trying to demonstrate here is that basically when you can have like this policies applied to like a specific namespace.
We lost you again, Paul. I don't know if it's a headphone issue or just being shifted away from a tab or something. I think you're back, Paul, in terms of audio.
All right, so right, I am so.
Object, right? And I can say equals or contains a specific instance, and then I can select whatever I'm not.
Paul, we lost your audio there again for a second.
All right, so I'm just gonna turn off my just the all right, you know.
Sounds more consistent. So let's see if that works now.
Yeah. All right. So,
all of the data, all the pumps, all the lines, whatever you want to track in that model, and you click it in the top, and go back, you can click on it again, and you
use something with
There's one of those.
all this that's not
You can make whatever code you want for the data space. You can say, oh, that's installed, right? And then you have
Paul, I think we lost your audio again. Sorry.
to install it connected to whatever, you know, the middle of it you've gone through. It can all be linked, or you can create it from here, so you don't have to link or whatever it is, have the item in the Dropbox. Hopefully good, that sounds like.
All right, can you hear me now?
Yeah, we can hear you again.
All right. All right, so if you look at this tracing policy and you look at the kind, you would see that the kind of the CRD is actually tracing policy namespace. All right, so we're gonna go to take this and just apply it in a. So just to be sure I don't have a tracing policy. So I'm just gonna in another. I'm just gonna apply this namespace tracing policy in another.
We lost your audio again, Paul.
No,
You're back now.
All right, can you hear me now? Yeah, so sorry about that. Not sure what's really going on with my ISP today. All right, so I'm gonna share my screen again.
review your, approval and transit, Okay, yeah, so that's okay. So you can set this little workflow.
Let me know if you need my screen.
Yep, we're good now.
Perfect. All right, so basically what we're trying to achieve here is basically
we're basically trying to let's just start a pod with Python, basically running and running with Python in the shell. So this should get pods. Got this pods and they've been terminating forever. Oh, right. Okay. All right, so we've got this. I'm
We lost audio again for you, Paul. Sorry.
all right. Do you still have my audio?
We're back now. Okay, so Paul, I think you and I have been just chatting to make sure on this, but it looks like because of the internet issues, we'll go ahead and call it for today. I was super excited to see you had started some really cool stuff there, but it looks like what we're going to do is have it's like a cliffhanger, everybody. You'll have to tune back later to see the finale. But what we're going to do is go ahead and have Paul record this offline and send it in, and then we'll make sure we put this out there for those of you who are watching that demo and wanted to see that last part. So we'll go ahead and end it today. Sorry all for the technical issues. You know what? We all work in computers, and we know this sometimes happens. So thanks for coming in, Paul. It was really great to see you again here and be able to talk some more about the stuff Isovalent's been doing with Tetragon. So let's go ahead and we'll wrap this up for now. And you'll be able to see this recording here soon, and we'll let people know where that's at. So thanks again for coming, Paul, and we'll see everyone at the next Cloud Native Live.